Okay guys, so here we are for example 5 on chapter 7.3, which is the section on friction and static particles. So if you're sort of taking notes or want a heading, this will be friction and static particles. So here we go, let's read through the question, pick out the key facts. Mass of 8 kilograms rests on a horizontal plane which is rough. The mass may be modelled as a particle. The coefficient of friction between the mass and the plane is 0.5. Find the magnitude of the maximum force P newtons, so it's the magnitude of the maximum force P newtons which acts on the mass without causing it to move. Without causing it to move, the force P is horizontal for part A. So let's get a diagram of that. So we've got a rough horizontal plane. We've got a mass of 8 kilograms. We've got a force P acting horizontally. We've got a weight 8g acting down. So that was P. Mu is equal to a half. What else have we got on there? We've got a normal reaction, R, and we've got friction opposing P. Let's just read that through again and check we've got everything on. 8 kilogram mass, rough plane, friction is a half. Find the magnitude of the maximum force P which acts on this mass without causing it to move. So, what do we need to do? Well, it's a horizontal plane, so in a standard kind of situation we resolve parallel and perpendicular to the plane. So, resolve parallel to the plane. P minus the friction is equal to 0 since equilibrium. It's on the point of slipping. Resolve vertically. R minus 8g equals 0 since equilibrium, so R equals 8g. On point of slipping, so friction is equal to mu R, and now we can substitute in from above. So R equals 8g goes in for R, and the friction is equal to P. So we can substitute in for the friction. P equals mu is a half and R is 8g. So P equals 4g newtons. Well, g is 9.8, so that's 40 minus 0.8 is 39.2 newtons. You can check that on a calculator. Okay, so that was part A. Go back, read the question. What have we got for part B? The force P acts at an angle of 60 degrees above the horizontal now. Okay, so have a quick go at drawing the diagram. You can pause this while you do that and then check it against what I'm about to do. Okay, so here we go. We've got the same idea. We've got a horizontal plane. We've got a weight, 8g, acting downwards. We've got a normal reaction, R. We've still got a friction opposing the motion. And this time, P is 60 degrees above the horizontal. So P is 60 degrees above the horizontal. And mu is still equal to a half. Okay, so approach is exactly the same. Resolve horizontally. Now this time we need to take a little bit more care with the forces because P isn't horizontal, so we've got to break it down into its components. So we've got P cos 60 adjacent to the plane, adjacent to the angle, P sine of 60, which is perpendicular to the angle, opposite, perpendicular plane, opposite the angle. So now we can work through this. Working horizontally, we can see that we've got those two forces there. So we're going to get P cos of 60 minus the friction is equal to 0, since equilibrium. Okay, so friction equals P cos of 60. If we resolve vertically, this time we're going to need that, and that. They're our vertical components. So we can come back and write those down. So vertically we've got R plus P sine of 60 is equal to, minus 8G equals 0, since it's equilibrium. So they were our vertical components, and that was our horizontal components. Okay, now if we look at those, we've got two equations with two unknowns. Oops, not two unknowns. Let's check. How many unknowns have we got? Friction, P, and R. So it's not two unknowns, but it's three unknowns. Therefore, need a third equation. Well, where's that going to come from? Well, in the question, as we go back and have a look, in the question, what are we told? We're told that it's from the magnitude of the maximum value of P. Yeah, so we're looking here. Find the magnitude of the maximum force P without causing it to move. So just like last time, it's still on the point of slipping. So on point of slipping, friction is equal to mu R. So friction is P cos 60. Mu, I think, was equal to a half, yeah. So we've got equals a half, and the normal reaction R we can take from here. So R is equal to 8G minus P sine of 60. So we've got a half of 8G minus P sine of 60. So now we're into a familiar context. We've got one unknown P. We've got one unknown P, but it appears twice. So we should know what to do. All terms with P to one side, rest to other is the first step for that, isn't it? So we've got P cos of 60 equals 4g minus a half p sine of 60. Add the half p sine 60, so we've got p cos 60 plus a half p sine of 60 equals 4g. The next thing that we then had to do is to factorise, because instead of p appearing twice, we want it to appear once. So you get p cos of 60 degrees plus half sine of 60 equals 4g. Okay, and then we can divide down by that. So p is equal to 4g over cos of 60 plus a half sine of 60. Well, 4g, cos of 60, we should know is a half plus a half root 3 sine of 60 is root 3 over 2. Well, first of all, we multiply top and bottom by 2. That's nice and easy. We're going to get 4g over 1 plus root 3 over 2. If we multiply top and bottom by 2, that shouldn't be 4g now then, that should be 8g, shouldn't it? Okay, if we multiply through by 2 top and bottom again, we're going to have 8g over, sorry, not 8g now, it'll be 16g over 2 plus root 3. And if we wanted we could tap that in the calculator, but if we were just practicing a little bit of our pure maths and we want to rationalise the denominator, we're going to multiply this by 2 minus root 3 over 2 minus root 3. So just as a reminder then, so we'd get 16g times 2 minus root 3 all over, could use our grid at the side, 2 minus root 3, 2 plus root 3, 4 minus 2 root 3, plus 2 root 3, minus 3. So these bits will cancel, and 4 take away minus 3, this whole thing then just gives us 1. So we've got a nice exact answer at the end. P is equal to 16g lots of 2 minus root 3. You could still tap it in a calculator. That would be roughly 160 and roughly, well, it's about 0.3, just over a third, so it's going to come out to be about 50, but 40-ish probably. Yeah, around 40. Around 40. Tap it in the calculator and we get 42 newtons approximately. Okay, hope that helps. I'll be going through example 6 shortly.